some background on what you want to do and so on and so forth. Now I just want to go into Blackboard. Let me see, Nicole, okay, you guys online seem okay. We'll go into Blackboard, and under the Final Projects tab, okay, you have, I'll put up a couple more data sets also. You have, just want to show you, okay, final project description, just so we go over this. Basically, and I'll show you, let me get this, open up this illustrated layout. Okay, this is what your project's going to look like, basically. You're going to have different, you're going to have a title, you have your name up here on your title, affiliation, if you have any affiliation, you want to put it down there. An introduction and abstract, descriptive statistics that you did for your data. For instance, one of the things I didn't do was, I didn't do the average for metacarpal length, or the average for height, stature. I didn't bother to do a frequency bar chart for how many people were unemployed versus how many people were employed in this population, or how many bar charts for how many were employed or unemployed in each category of education. I could have done bar charts for that. Those are frequency, basically frequency counts. In categorical variables, you're doing frequency counts. So you might want to put something in there that describes the data that you're working with, the averages, the number. If it's categorical, you're not going to do averages. You're going to do just counts, right? If you're doing numerical, working with numerical data, you're going to do averages. One of the things I didn't show you here was a t-test or analysis of variance. Where would we use those? We would use those where one is a categorical variable and the other is a numerical variable. For instance, if we wanted to compare marital status to BMI, BMI is a numerical variable, right? So if we have well, let's say gender, okay? Gender is definitely just going to be male and female in our category. It's going to be two categories, right? So you can do a t-test, right, to determine whether the average BMI for males is different than the average BMI. Which one is different than the average BMI for females? Anybody want to hazard a guess what it is? Is it the same? I mean, it's based on, you would think kind of, it may not make any difference because women are lighter, but they're shorter in general. Anybody want? Let's give it a try. Why not? Okay, I'm going to go back to SPSS. Let's give it a try. We have the data for it. I'm gonna reopen this data file. Use data. Oh, it's already open. It knows I already opened it. Revert to save version. Okay, just reopened it. Okay, so now let's see, where's gender here? Here's BMI, I know where it is, right? BMI is here. And gender is BMI, and gender is down here somewhere. Sex, I guess. Yeah, male and female. Okay, so it's going to be BMI and sex. So now, if I go to my data view, or I could do it there, in my variable view also, I could literally just highlight and clear out all the unneeded variables. I'm not going to bother with that. I'm just going to go up here to Analyze. Compare means, because we're now looking at a t-test. So we're going to compare the two means, a mean BMI for females, mean BMI for males. They're independent samples, right? They're males or females, randomly sampled over the phone. It's not paired samples, it's not compared to one number. Independent samples. So I'm looking at BMI, is my test variable, the thing I'm going to find the average of. And my grouping variable is gender or sex. Sex, male or female. I'm going to put that in my grouping variable. I got to define my groups. Now, what were my groups? Was it 0 and 1 or 1 and 2? Let's see. Sex is 1 and 2. Okay. Define my groups. 1 for male or female, 2 for the other. And I'm going to click OK. And SPSS will do that for it. Counted. There were 3,500 males, 4,900 females. The average BMI for males is 26. The average BMI for females is 27. It's a little bit different, right? Is it significantly different? Statistically significantly different. Let's take a look. Here's our t-test. Well, do I use the top row or the bottom row? Well, these 4 boxes here, if we recall, we even did this on a test, right? These 4 boxes tell you, starting with the null hypothesis that the equal variances are assumed, that the 2 variances are equal, the significance is less than 0.05 for this test of quality of the variances. So I can reject my null hypothesis because it's less than 0.05 and say that they're not equal, the variances. Okay, so I'm going to use the bottom line instead of the top line. So what is the t-score? T-score is negative 1.583. And what is the significance, the p-value, the probability I'll be wrong if I reject the null hypothesis that these 2 BMIs are the same? Well, it's 0.114. Can I reject my null hypothesis? It's bigger than 0.05, right? So I can't reject my null hypothesis. So this is not, there's a difference, right? It's a very small difference. If I look closer, 26.94, 27.14, I can't say that that difference is big enough to say that the difference in BMI, male to female, is not due to chance. Well, that's important, right? Because think about it. If BMI were different based on gender, think how much harder it would be to apply. We'd have different scales. We'd say, oh, obese for females is this much. Obese for males is this. Right? You guys agree with me? In other words, it's good that they're the same for males and females in this formula, just in terms of the way we would apply this formula. Okay? That's the way I would do a t-test to see if my null hypothesis that there's no difference in BMI, average BMI for males and females in this population. Okay, my alternative is that there is a difference. Now, notice it really didn't matter if I picked out the top one and the bottom one. They both have a p-value, a significance greater than 0.05, so neither one of them would have let me reject the null hypothesis. Now, what if I had more than 2 groups? This is male and female. What if I did the same thing for, remember our employment status before? That was 4 groups. Oh, that was 3 groups. How about educational status? That was 4 groups. Let's say I want to compare the average BMI for each one of those 4 groups. Now, I'm still going to that's still a categorical variable, numerical variable. Instead of using a t-test, what test am I going to use? Analysis of variance, right? We use analysis of variance. We use t-test when we're comparing 2 means. We use analysis of variance when we're comparing more than 2 means. So let's do that one. That sounds like a perfectly good one too. You could go home and do that one too if you wanted to. Let's do that one right now. Okay, so yeah, it could be that high, Nicole. Now I'm going to go, it could be that high if for no other reason. The sample sizes are so tremendous in here. Let's see, and also because the number of degrees of freedom are very high. In other words, it's 2 by 3, a 4 by 3 table. There's 12 boxes instead of 4. So okay, let me get back to the point. Okay, let's see, analyze, compare means. Except I'm going to go to one-way analysis of variance. Okay, so now my groups are going to be education level. BMI is going to be my number that I'm going to find the averages of, my dependent. Okay, my factor that I'm going to break that up into and find averages for different educational levels. Okay, let's see. You remember where that was? employment status, educational status. Okay, I'm going to put that in there. And now it's not going to ask me to figure out what numbers, it's not going to ask me, it only does that on t-test in case you have more than two variables. Okay, it doesn't care how many variables, that'll do it for all of them. And, okay, let's see. Here's my analysis of variance. My F value comes out to be 74. It's a pretty big number, right? Even for 3 degrees of freedom, that's a big number. My significance is 0.000. What's my null hypothesis here? My null hypothesis here is that there's no association between education level and BMI. But what does this 0.000 tell me? It tells me that I can reject my null, it's less than 0.05. It tells me I can reject my null hypothesis and say there is an association between educational level and BMI. Okay? And in fact, if I use descriptive, what's this? Descriptive, remember we're talking about descriptive statistics, right? I'm going to go down to explore, and I'm going to say, okay, so tell me BMI, tell me what my body mass, average body mass index is for each of my factors in my factor list, which was educational level. Let's see what that is. ANOVA doesn't bother to tell us that; just tells us that it noticed that there is a difference, or we can reject the null hypothesis that there is no difference. So I'm looking for employment status. And I'm going to say, let's see, okay, it's going to do all our statistics. I'm going to ask it also do a histogram. Why not? I'm going to say, okay. Let's see what it does for us. It's going to break up BMI into 4 groups by employment status. Okay, and let's see. If you're employed, your average BMI is 26.67. If you're unemployed, your average BMI is 27.58, almost a full one up. If you're not in the labor force, it's 27.49. So now, I didn't mean to do that, right? I meant to do educational status. By the way, look at, you can also, histogram kind of suggests that it is a normal distribution. There's our bar charts are printed out first. Let me go back and do what I meant to, which was I meant to do compare means, descriptive statistics, explore. I didn't mean to do employment status. I meant to do educational status. Click OK. Okay, here we come with educational status. Less than high school, 28. High school, 27. College, 27. College graduates are the skinniest in the bunch, 25.98. Interesting. There's a relationship between BMI and educational status. That's interesting stuff, right? That makes a great project, right? And you also saw it with employment as well, right? So let's see. Now the thing is that we've done our the data is a little skewed, right? You can see that like, and that's not unusual, I guess, with weights, right? Because you don't get too many people that are really underweight, but you do tend to get more people that are more of a spread towards higher weights than lower weights, right? So you wouldn't expect it to be perfectly normally distributed, but you can see the distributions. You have histograms for each one of your groups. Okay, so now we have descriptive statistics, and now we already did our compare means, analysis of variance for the 4 groups, and we got, I'll do it again just so I can get the table back, and we got a significant result. We can reject the null hypothesis that there's no association between educational status and BMI. But do I know which of the groups are different? Is high school group, not graduated high school group, different than the college group? Or is the some college different than college graduates? What do I do to find out which of the groups are different, really different from one another? If I do analysis of variance, what kind of analysis do I have to do? Right? After I get to this point, I know you guys know this. You've just did this, right? Right? What do I do now? Analyze. What do I do now? Is it compare means, one-way analysis of variance. What am I going to do now to figure out whether or not which of these groups are different from one another? Right? Most of you finished up that homework. Right? What'd you do after you did the analysis? Post hoc test, right? Okay, it's like pulling teeth. Thank you very much online. At least I didn't pull teeth online. Okay, so I'm going to hit post hoc test, right? And I'm going to choose one of the more popular ones, Bonferroni or Tukey. I'll choose Bonferroni. I'm going to click continue and OK. Does the analysis again, except this time it analyzes each group relative to the others. And what I'm looking for is a significance that's less than 0.05. So this is less than 0.05. So less than a high school diploma and high school graduates, there's a significant difference in BMI for that group. Less than high school versus some college less is also true. Less than high school and college is also true. So I can tell that between this less than high school versus all three of these groups, there's a significant difference. High school versus less than high school was the same analysis we did before. High school versus some college, well, no, that's not a significant difference. How about high school versus college graduates? That is a significant difference, and so on and so forth. You can use the post hoc test to tell you which of these groups are different from one another. Okay, so you're going to wind up, you got some descriptive statistics, you got some your analysis of the data. So you're going to wind up being able to, let me go back here, see if I can't find it again. Where am I? Here we go. Okay. You will then put this together, and many of you started to upload this. You know, the guys that uploaded it early gave me a chance to like give them some feedback, you know, on what they were doing and give them some advice and so on and so forth. So some value to that, I hope. So this is basically the layout. In reality, I think the boards will take 3 pages across, and most people I think are using either PowerPoint or Word to do them in landscape form because it's easier. You're going to make them. You're going to use fonts that are big enough for us to read, you know, in front of us, and so we don't have to squint at it and stuff like that. There's a couple of it in the instructions. I'll go back here. In the final project description, there are instructions on suggested font sizes, you know, what these different sections should include, right? Results, and basically what I'm going to be looking at in terms of grading them. Okay, so you'll get an idea what's going on. Now, I posted a couple of pictures. One of the pictures I posted was samples from last semester. And I purposely made them a little blurry so you wouldn't actually just copy them. Yeah. This is actually 3 different presentations. They were actually really, let's see if I can't get this to stay here so I can. Let me see if that copied out. Yeah, here we go. I'll get this to zoom up. This is actually 3 different presentations. Okay, they most likely because the board is wider than it is long. It's 2 feet wide and 2.5 feet long. So you have enough room to kind of get 3 across. So most of them were displayed 3 across, or you could do it 2 across. So this one over here, you can see they gave their introduction. They did the descriptive statistics. They did their output. They discussed what they found, their methods, some more output, and then they listed the references. In other words, nothing else has popped up. If you're doing something that compares BMI and educational status, you want to go research that and put in some information about, well, you know, why has anybody else studied this? What have they found? Are there reasons why this is true? I mean, it has something to do with poverty and access to a better diet and so on and so forth. You can speculate on why we see this distinct difference in these groups in terms of BMI based on their educational levels. So or employment, so on and so forth. So you might want to speculate on why that's occurring. So this one, here's one. I mean, if we're not talking about a ton of typing and stuff like that here, ironically, this one in the middle here was the highest score last year. Okay. Now you would say, gee, that doesn't look like they did as much work as the other one. This one was so concise, and the statistics, the method was perfect. It was concise. They had references. You could look at this and just, I mean, in a few minutes, understand everything that they were presenting. It was clear as could be. Even though I would have loved to have seen them use a little bit of graphics in here, because I think that always helps clarify things a little bit. They didn't need it because it just worked well, but in most cases it helps if you have graphics. That one got the highest score, and certainly wasn't the most voluminous, and certainly wasn't. And that there were three of us grading last year, right? Kind of round robin, because there were three instructors, and all three of us rated that one the highest, right? So it wasn't an accident. Okay, so think about your methods, be concise. It helps if you have some graphics. I think for the most part, the other two were the second and third, right? Highest scores, right? So they all use graphics quite a bit, but it just turned out this person just like really kind of, hit a home run in terms of like keeping it concise and really delivering a lot of information. So at any rate, that's what they look like last semester. They did them usually as landscapes because they just fit the paper better. And a lot of people have been emailing to me that have been uploading them, have them as Word documents, some of them. Others have them as PowerPoint documents because PowerPoint's easy to, place in text pages and, drop in graphics and move them around a little bit easier than Word is. But that's up to you guys. You can do it either way you want. Okay, but print them out when you come in on Wednesday, right? We're going to, first 15 minutes, we're going to do two groups. First group, we're going to I'll draw lots. We'll have, 10 or 12 people that will set up their presentation, kind of like poster session. I'm going to see if I can't get another room where we have a bit more space. The first 10 or 12 people will set up their presentations, and I'll go around, and Levi's going to stop by too. We'll go around person by person. I got an egg timer, right? Remember the little sand egg timers? I got one of those. You got 3 minutes each for your presentation. You can explain to me what you did, how you did it, and what you found. And you'll also upload it to Blackboard in the space that we provided for you. And between what we see here and what we see there, we'll put together a grade for it. Okay? So I encourage you to you got a few days left, a couple of days left. So have some fun with it. This is an opportunity to look at these things and get a feel for how you would really use this kind of stuff, how you would use these tools. And the other half of you will, since you'll be doing you'll be waiting for them to get done, you'll have a chance to go around and look at their presentations, talk to them. Well, we're getting around, you can talk to your fellow students, see what they did, and then we'll swap, and the other guys will have 15 minutes to set up theirs, tape them up. We'll bring push pins or tape or something like that, so that you guys can tape these things up on the boards that we'll provide. So, any questions? So we looked at a few different ways. Number one, descriptive statistics. Number two, if we got categorical statistics, we use chi-square. If it's 2 by 2, we can use odds ratio and relative risk, but a lot of these are not 2 by 2. If it's categorical numerical, we can use t-tests, or we can use analysis of variance, and so on. So pick out stuff. Hopefully you guys kind of settle into something already. Pick out stuff that you think is interesting and run with it. Yes, good question.
Yes, you chi-square test, you said definitely a cell less than 5, not good. But what about 5?
5's okay.
5's fine.
Yeah, and if you had 4, I wouldn't object anyway. Because part of the problem we have is it's tough to find suitable data. Because people publish stuff and they have articles, but very rarely do you actually see the raw data. So it makes it a little bit more difficult for us. That's why we're using the community health survey. That's why I threw up a bunch of, oddball kind of. We also have data from the Framingham study, that hard study. We also have data from, what else did I put up there? I forget. There was another one too, another heart or cholesterol study from somewhere. Digitalis study maybe, and a description of what the variables were for that. So you could use one of them instead. And those I think were SPSS files. So you have a ton of resources there, but go ahead and run with it. And like I said, I got a window tomorrow night where it's going to be tough to get in touch with me. But beyond that, even late, I should be able to answer some questions.